Hello everyone. In the previous video on quadratic equation, we saw how do we find the sum of the roots of a quadratic equation and how do we find the product of the roots of a quadratic equation. In this video, we will understand how do we use the roots to form a quadratic equation. Once we have the roots available with us, how do we form a quadratic equation? We will see that in this particular video. Subsequently, we will also solve some of the problems and we will understand more about the roots. What are equal roots means what, imaginary roots means what, real roots means what, all those things we will understand, right? So now we will enter into our session. We had already seen, in case if there is a quadratic equation having roots alpha and beta, and we had seen that the sum of the roots for a general quadratic equation, if the quadratic equation is ax square plus bx plus c equal to 0, then we had seen in our previous session that sum of the roots is minus b by a, and then product of the roots POR is c by a, where alpha and beta are the roots. Now here we are going to understand how do we form a quadratic equation if the roots of the same are known. Let us go back to our quadratic equation. The quadratic equation is ax square plus bx plus c equal to 0. Now dividing both sides by a, what do we get? We get, if I divide ax square by a, it will become simply x square, and this will become now b by a times x, because you are dividing by a, and this will be c by a. 0 by a is 0 only, right? Now we already know sum of the roots is minus b by a, but here it is actually b by a. So I can modify this as x square minus of minus b by a, because we know minus into minus is plus, times x plus c by a equal to 0. So I can now write this as x square minus, we know b minus b by a is nothing but sum of the roots. So I can say sum of the roots times x plus c by a, we know it is product of the roots, equal to 0. Means if I know the roots, I can simply add those roots, write it here, put a negative sign here, then product of the roots, I can multiply those two roots and write that here. This will be our desired quadratic equation. So that way, once we have the roots, I can also write this as alpha plus beta times x plus alpha beta equal to 0. So this will be our desired quadratic equation. Now let us understand further about this, the formula whatever we have to solve a quadratic equation. We know if ax square plus bx plus c equal to 0 is a quadratic equation, then the roots are, that we had already seen, it is x equal to minus b plus or minus square root of b square minus 4ac by 2a. Now, if we look into this term, I am just marking it in red. Or to be very precise, let me remove this. Let me go inside the bracket and put that red marking. Now, let me say, if I consider this b square, if b square minus 4ac, suppose if this term is 0, then what happens? You don't get two roots, you get minus b by 2a only, because this is 0 means square root of 0 will be 0. So minus b by 2a will be the root. Means we say one root will be minus b by 2a, even the other root also will be, because what will happen if this is 0, then x will be minus b plus or minus 0 by 2a. So I can say it is minus b plus 0 by 2a minus b minus 0 by 2a. That will also be minus b by 2a. Means you say the solution has got equal roots. That is, the solution has equal roots. This is when this particular thing means b square minus 4ac is 0. Then second, if the inside the square root, if that is positive, means anything, whatever I'm having, suppose if this result within the square root, if it is positive, what will happen is, no issues, I can still find out the square root, means the whole solution will be real numbers. So I can say then the solution will have real numbers. I mean, you will get a proper real number only. But in case if this b square minus 4ac, if it is lesser than 0, means if this inside the square root, if it is negative, then what happens? Square root of a negative number becomes an imaginary number, right? So you call then the solution will have imaginary numbers. So these are the three possibilities, means either the solution will have equal roots when this inside the brackets is 0, or if the inside the square root, if it is positive, then I can get real number as the solution. Then third, if this is negative, what will happen? Square root of a negative number will give you an imaginary number. So we get actually the solution as imaginary number. So these are the three different possibilities which we can remember. Okay, now let us try to solve some problems based on our learning now. First question. Determine the quadratic equation whose roots are 3 and minus 2. Say, roots are known. We are supposed to form a quadratic equation. How do we do that? Let us say, let alpha equal to 3 and beta equal to minus 2. We know sum of the roots is alpha plus beta, which is 3 minus 2. I mean, I'm adding 3 and negative 2. You get simply 1. Then product of the roots, which means alpha multiplied by beta. So it is 3 multiplied by minus 2. We get negative 6 as the result. Therefore, the required quadratic equation will be, already we did here, How? Here, x square, I will have to write it first, minus sum of the roots, whatever we calculated, we'll put that one into x plus the product of the roots should be equated to 0. We can simply do that. Will be x square minus sum of the roots. Sum of the roots we calculated here, it is nothing but 1. So it is 1 times x plus product of the roots. Product of the roots is negative 6 equal to 0. Or simply I can write x square minus x minus 6 equal to 0. Now, is it correct or not? We can even check. How? Considering this as quadratic equation, let us find by using the formula method, do we get these two things as the roots? Let us check that. I'll say check. So here our A is 1, B is minus 1, C is negative 6. So we know the formula is x is equal to minus b, minus of minus 1, plus or minus square root of b square minus 1 square minus 4 into A into C by 2 times A, 2 times 1. Minus or minus 1, it becomes plus 1, plus or minus square root of minus 1, the square is 1, minus into minus, it becomes plus, so it is plus 24 divided by 2. So what is that? It means x is equal to 1 plus or minus square root of 25 is 5 divided by 2. So which is 1 plus 5 by 2 or 1 minus 5 by 2, which is 6 by 2. 6 by 2 is 3 or minus 4 by 2. It is negative 2. So we got back the same roots what was given initially, 3 and minus 2. So definitely this methodology is perfect. Means if the roots are known, we can very well find out the required quadratic equation. What should be the quadratic equation can be found by applying this style, x square minus sum of the roots times x plus product of the roots is equated to 0. Right? So that is the verification for whatever we did. Now let us move on to the next question. Right. The question says, if 5 is one root of the quadratic equation, x square minus ax equal to 15, find the value of a. What it says, one root is known to be 5. Let the known root equal to alpha, and that is known to be 5. Unknown root is, and let the unknown root equal to beta. We don't know what is it. But one thing we know, sum of the roots, that is alpha plus beta, should be minus b by a. That means 5 plus beta, because alpha we know it is 5, one of the root. Beta we don't know, I am simply writing beta. Minus b, here what is minus b? If you look into, it is b is minus a. So if it is minus b, then it is minus of minus a. Why I am writing that? We know b is negative a. So minus is already there, I am keeping that. When b is negative a, I am substituting that, divided by a. A is 1 because the coefficient of x square is nothing but 1. So it is 1 only. I can simply write it as minus or minus a, which is plus a. So it is simply a. So a is 5 plus beta. Now, product of the roots. What is product of the roots? Alpha, beta, which is, we know it is c by a. What is alpha? It is 5. So 5 times beta is equal to c. What is c? I need to rewrite this equation. How do I rewrite? I can bring x square minus ax minus 15 equal to 0. Now I can say our C is negative 15. So negative 15 by negative 15 by A. So now from this I can say cross multiplying A is equal to minus 15 by 5 times beta or minus 3 by beta. This is also A, this is also A. I can equate it. So, or rather I can substitute it here. How do I do it? C by A. Oh, I made a mistake here. Just a minute. We know here A is alpha plus beta minus B by A. So it is A. Okay. Here it is C by A. This A is nothing but, this A is nothing but 1. Let me rub it and rewrite it. So the problem is this question is also having the small a. What we will do is we will equate this to the general or I can make everything to capitals. Let me do this so that there is no confusion, because here also this a is there, this a is there, this is capital, I'll make it right. So 5 beta, and here capital A is nothing but, capital A is nothing but 1. Then now confusion will not be there. That means our beta is minus 15 by 5, which is negative 3. Now that we have beta value as negative 3, I can substitute it here as 5 minus 3, which is 2. That is what we require. We require the value of small a. What I did is, instead of bringing in the same small a, like I am considering the general quadratic equation as ax square plus bx plus c equal to 0. Why? Because here also we have small x. That small x, if I write here also small x, we have confusion. For that reason, I made it as all capital letters. So sum of the roots is minus b by a. I wrote capital B by capital A. Product of the roots is C by A, capital C by capital A. That I had made a change so that this B here, that small a is coming, that should not confuse us. For that reason, I converted everything into capitals, nothing else. Right. Let's move on to the next question. Next is form the quadratic equation whose roots, are cube of the roots of the equation 2x square plus 4 equal to 6x. Given quadratic equation is 2x square, they gave us plus 4 and then equal to minus 6. Let me bring that minus 6x to the left side. It will become negative 6x plus 4 equal to 0. I can simplify this by dividing both sides by 2 as x square minus 3x plus 2 equal to 0. Now they say you need to form a new quadratic equation. This is actually a new quadratic equation whose roots are cube of the roots of this equation. That means first I need to find out what are the roots of this particular equation. What are the roots for this particular equation? So let's find out the roots for this equation. X is equal to minus b, minus of minus 3, plus or minus square root of b square minus 4ac by 2a. So that becomes 3 plus or minus square root of 9 minus 8 by 2. So it becomes 3 plus or minus 1 by 2. 3 plus 1 by 2 will become 2. That is 4 by 2, 2. Another one is 3 minus 1, which is 2. 2 by 2 is 1. That means the roots of this quadratic equation is 2, 1. Whereas for the desired quadratic equation to be formed, for the desired quadratic equation to be formed, the roots are cube of these two roots. I need to consider the cubes of these. 2 cube, 1 cube, which means 8, 1. That means for the desired quadratic equation, the roots are 8 and 1. The roots are 8 and 1. Therefore, the desired quadratic equation will be x square minus sum of the roots times x plus product of the roots equal to 0. That will be the, what is that? X square minus sum of the roots means 8 plus 1 times x plus product of the roots 8 into 1 equal to 0, which means our required quadratic equation is x square minus 9x plus 8 equal to 0. That's all. So what we did, whatever equation which was given, we first found out the roots by using the formula. We got the roots as 2 and 1. Then the question says, form a new quadratic equation, a quadratic equation whose roots are cube of the roots. Already we found the roots. Now we took the cubes of that. 2 cube is 8, 1 cube is 1. Considering those two as roots, we formed the quadratic equation. That's what we did in this question. Let's move on to the next question. If alpha and beta are the roots of the quadratic equation x square minus 3x plus 5 equal to 0, then find the value of alpha square plus beta square. First of all, we are supposed to find alpha square plus beta square. From where we will find, we will consider alpha plus beta the whole square. It is like a plus b the whole square. What is that? It is a square, sorry. I'll say instead of a square, it is nothing but alpha square. Alpha square, a square plus b square plus 2ab. Means I can rewrite this as alpha square plus beta square is equal to alpha plus beta the whole square minus 2 times alpha beta. Means if I have to find this, I need to find this and I need to find this. What is the quadratic equation given? Given quadratic equation is x square minus 3x plus 5 equal to 0. Now, sum of the roots is nothing but alpha plus beta, which we know it is minus b by a. What is minus b in this? It is minus of minus 3. What is a in this? It is 1. So it becomes 3 by 1. So it is nothing but 3. Means sum of the roots is 3. Now, product of the roots is alpha beta. Alpha beta, we know it is C by A. What is C here? It is 5. What is A here? 1. So it is simply 5. Now, I have the value of alpha plus beta as 3, alpha beta as 5. We can substitute it here. Therefore, I can say, therefore, alpha square plus beta square is equal to alpha plus beta, the whole square, minus 2 times alpha beta, which is 5. That means this is 9 minus 10. So the result is -1. -1 is the answer. Let me move on to the next question. Here, alpha and beta are the roots of the equation x square plus px plus 7 equal to 0. Right. So these are the things which are given. First of all, let us rewrite the equation. This implies alpha plus beta, because the question already said that alpha and beta are the roots of this. So sum of the roots will be minus b by a. Here b is nothing but p. So minus p divided by a. A is nothing but 1. Coefficient of x square is 1. So the result is minus p. Means sum of the roots is minus p. Then product of the roots, alpha, beta, we know it is c by a. Here c is 7 and a is 1. So the result is 7. Now, alpha square plus beta square value is given. We already know in the previous problem we had seen alpha square plus beta square is nothing but alpha plus beta, the whole square, minus 2 times alpha beta. Now, this alpha square plus beta square value is given as 22. Let me substitute 22 is equal to alpha plus beta the whole square, means minus p the square minus 2 times alpha beta is known to be 7. So that means we will have 22, and then this negative 14, I will take it to the next side. It will become positive 14 is equal to p square, which means this is 36 equal to p square. That means p will be plus or minus 6. Value of p is plus or minus 6. Why? Because you are taking a square root of 36. That is the solution for this problem. Let me move on to the next question. Given p square equal to 7p minus 3 and q square equal to 7q minus 3, where p, I'm sorry, here it should be p is not equal to q. Let me rub it and write it. Here p is not equal to q. Yeah, I think I made it. P and Q are different. P is not equal to Q. So if P square minus 7P plus 3 equal to 0 and q square minus 7q plus 3 equal to 0, where p not equal to q, then I can say what I did. I just took these terms to the left side. So this becomes negative, this became positive. Same thing I wrote. You may notice both are same except that here it is P, here it is Q. But they also say P is not equal to Q. Then I can conclude, then uh, P not equal to Q, then I can say, then we can say that P and Q are the roots of a quadratic equation. I will write general quadratic equation as, instead of P or Q, I will simply write x square minus 7x plus 3 equal to 0. Suppose for this quadratic equation, the roots are P and Q. That means what? Both Q and P will satisfy this equation that they had given in the question itself. Means if I put P instead of X, I should get the result as 0. If I put P, what will happen? P square minus 7P plus 3 equal to 0. That is already given in the question. And if I put Q, it will become Q square minus 7Q plus 3 equal to 0. That is also already given in the question. That is why I am concluding that P and Q are the roots of this equation, which means when I know P and Q are the roots of this equation, I can say sum of the roots, which is P plus Q, should be minus B by A. What is minus B? Minus of minus 7 by A, which is 1. So I can simply say 7. Then product of the roots, P into Q, is C by A. C by A means here 3 by 1, which is simply 3. So we got P plus Q as 7 and PQ as 3. Then further, the question is asking us to form a quadratic equation whose roots are P by Q and Q by P. Let us see that. If the roots of a quadratic equation are P by Q and Q by P, then the sum of the roots, what do you mean by sum of the roots? P by Q plus Q by P. So I will take an LCM. LCM is Q into P. I can also write it as PQ. And then P into P, you will do multiplication. This P into this P, this Q into this Q. That means numerator will have P square plus Q square. And we also know P square plus Q square can be written as P plus Q the whole square minus 2 times PQ. How I wrote this? Same thing what we did with alpha and beta. Somewhere we wrote here. Alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta. Instead of alpha beta, I considered P now. That's all. P and Q. So I am writing the numerator P square plus Q square as P plus Q the whole square minus 2 times PQ divided by PQ. Now, this is sum of the roots. So that means sum of the roots will be, what is P plus Q? Already we evaluated. It is 7. So 7 square minus 2 times, what is P into Q? P into Q is 3. Divided by PQ is again 3 only. So this is 49 minus 6 divided by 3, or I can write it as 43 by 3. This is sum of the roots. Now let us move on to product of roots. What do you mean by product of roots? The roots are P by Q and Q by P. I need to multiply that. P by Q into Q by P. If I multiply both P and P, Q and Q gets cancelled, you get 1 only. Therefore, the desired quadratic equation having roots P by Q and Q by P will be, how do we write it? We write x square minus sum of the roots times x plus product of the roots is equal to 0. Now, x square minus, what is sum of the roots? We already calculated 43 by 3. 43 by 3. Here x is there, plus product of the roots is 1. But generally, any quadratic equation, or rather any equation, you generally avoid the fractions. So what you do, you avoid fractions. So what you do, you take an LCM as 3. What will happen? This will become 3 into x square, 43x plus 3 equal to 0. Again, cross multiplying, we get this will become 0 by cross multiplying. So the resulting quadratic equation is 3x squared minus 43x plus 3 equal to 0. That is the result for this particular problem. Now let me move on to the next question. The question says, if the roots of the equation ax square plus bx plus c equal to 0 be in the ratio 2 is to 3, then find the value of 6 times b square in terms of c plus a. What do you mean by in terms of? I need to express 6 times b square equal to something which will have c and a. What is that something which will have c and a? We need to see. Now, let the roots be alpha comma beta. Now, given alpha by beta is 2 is to 3. So I can write 2 by 3. Cross multiplying, we have 3 times alpha equal to 2 times beta. Or I can rewrite it as alpha is equal to 2 beta by 3. Now, sum of the roots, alpha plus beta, we know it is minus b by a. And product of the roots, alpha beta is c by a. Right? Now, what is alpha? It is 2 times, let me call this as equation 1, this as equation 2. Let me write it based on equations. I can write this equation 1 as alpha. Alpha, we know it is 2 times beta by 3 plus beta equal to minus b by a. So further, I can take beta common. So you will have 2 by 3 plus 1 times beta equal to minus b by a. Or further, I can take 2 by 3, that is 3 as LCM. So you will have 2 plus 3 times beta is minus b by a. Or this is 5 by 3 times beta is equal to minus b by a. Right. This is one part. Let's keep this. Now coming to second equation. What is our second equation? Alpha beta. Alpha beta is c by a. Alpha beta is c by a. What is alpha? Alpha is 2 beta by 3. 2 times beta by 3 times beta is c by a. So I can rewrite it as 2 times beta square by 3 is equal to c by a. Now, here we have beta, here we have beta square. So what we will do, I will square this so that I will get beta square. So if I square it on both sides, 5 square is 25, beta square is beta square, 3 square is 9. Here it will become b square by a. So Now I can somehow equate this. Means I can write this as beta square is equal to 9b square by 25a. 9b square by 25. Here I can rewrite this as beta square is equal to 3c by 2a. That means from this I am having beta square. From this also I am having beta square. I can equate that. Hence, I can equate these two. 9b square by 25a is equal to 3c by 2a. Cancelling both sides a. Now, what is that we are trying to find? We are trying to find what is 6b square. So, is that possible to bring 6b square? 6b square. Here we are getting 9b square. Just a minute. Yeah, here it should be a square. Here also it should be a square. Right. So that means I can rewrite this as 9b square by 25a square. So if I cut it, I will have a still. Right. So what is that we are trying to find out now? 25, let me rewrite it by cross multiplying. So we will have 18b square is equal to 25, that is 75 times AC. Just a minute, just a moment. Now, if I divide both sides by 3, we will have 6 times b square is equal to 25 times AC. That means 6b square is nothing but 25 times AC. That is the question. Express or find the value of 6b square in terms of C and A. We already have the result having C and A. That means it is actually product of C and A multiplied by 25. So that is the result. So that is the solution for this. Now let us move on to the next question. Next question is, construct a quadratic equation whose roots are alpha cube and beta cube, where alpha and beta are the roots of x square plus 3x plus 2 equal to 0. Primarily, they gave us alpha and beta are the roots of this equation. So, for the quadratic equation, x square plus 3x plus 2 equal to 0. For this equation, they gave the roots as alpha and beta. So I can say sum of the roots will be minus b by a, minus 3 by 1. So it is minus 3. Then product of the roots, alpha, beta is c by a, which is 2 by 1, which is 2. Now we have sum of the roots, product of the roots available. Now the question is to construct quadratic equation whose roots are alpha cube and beta cube. So now if I have to construct, I need to find out the sum of the roots. Alpha cube plus beta cube is what that we have to find. Then secondly, I need to find the product of the roots, alpha cube, beta cube. That can be written as alpha, beta, the whole cube. Now, how do we arrive at this? First, let us consider equation alpha plus beta the whole cube. It is like a plus b the whole cube. How do we form that? It is a cube plus b cube plus 3ab into a plus b. That is the expansion for a plus b the whole cube, right? I can write like this. That means I can rewrite this as alpha cube plus beta cube is nothing but alpha plus beta the whole cube minus of 3 alpha beta into alpha plus beta. So this I'm going to substitute it over there on the top. So here I can write it as alpha plus beta, the whole cube minus 3 times alpha beta into alpha plus beta. Now all these values are available with us. Alpha plus beta, the whole cube means alpha plus beta is known to be minus 3. So this will become minus 3 the cube minus 3 alpha beta. Alpha beta is known to be 2. So this one. This I will substitute it as 2. Again, alpha plus beta is known to be minus 3. Substituting that, what is this? Let me rub it and write it below. Yeah. This we know it is 2 cube. 2 cube is 8. Let me put a box here. Now I will rewrite this. Negative 3 the whole cube will be minus 27 because minus into minus into minus. So it becomes minus. So it is actually 3 cube. 3 cube is 27. Then this one minus into minus plus 3 into 2 6, 6 into 3 18. So plus 18. We get the result as minus 9. Now we have the sum of the roots as minus 9, product of the roots as 8. So the desired quadratic equation, therefore the desired quadratic equation will be what? X square minus sum of the roots times x plus product of the roots equal to 0. Now, what is sum of the roots? Sum of the roots we already calculated. It is negative 9 minus of minus 9 times x plus product of the roots. Product of the roots available as 8. So it is 8 equal to 0. Or I can write it as x square plus 9x plus 8 equal to 0. So that is the result for this. I will write the next question as ninth question. Ninth question is the equation x square plus 2 times p plus 2 times x plus 9 times p equal to 0 has equal roots. Find the values of p. Find the value or values of p. The question says equal roots. So let me compare this with the general equation. I'm sorry, ax square plus bx plus c equal to 0. Let me say this is the solution. Let so and so be the general quadratic equation. If this quadratic equation has equal roots, then what? Then actually your b square minus 4AC should be equal to 0. We had seen in our start of this session about equal roots in the beginning. Let me go there once again. Here it is. If it is equal roots, then your b square minus 4ac should be 0. So that is what I am writing now. Instead of writing small b square and small a and small c, I am writing capital B just for clarity, nothing else. Just in order to avoid any confusion with small letters and capital letters, I am bringing all these things in capital letters. B square minus 4ac should be equal to 0. Here, what is b? Here the b should be 2 times. Means if I compare this and this, I will say here capital A equal to 1, capital B should be equal to 2 times P plus 2, and capital C should be 9 times P. I'm just comparing this equation with this equation. So I identified A as 1, B as 2 times P plus 2, and C as 9 times P. Now, if the quadratic equation has equal roots, means this should satisfy. What is that? B square. B square means 2 times square or 4 p plus 2 the square minus 4 times a, which is 1, and then 9 times p should be equal to 0. Expand this. First of all, I can divide both sides by 4. So this will get simplified to p plus 2 the square minus 9p equal to 0. Now expanding this, p square plus 4 plus 4p minus 9p equal to 0. And this further gets reduced to p square minus 5p plus 4 equal to 0. Now I can factorize this. I will have p square minus 4p minus p plus 4 equal to 0. Now in this common is p minus 4. Here I will take minus of p minus 4 equal to 0. Now in this common is p minus 4 times p minus 1. That means our p value is 4 or 1. So that is what we are supposed to find, the values of p, which we found it. It should be either 1 or 4. So that is the solution for this particular problem. So with this, we'll end up this session. In case if you find the contents of this video to be useful to you, I request you to please like, share it to your friends, and also subscribe to my channel. Thank you.